So, hi Jenny, it's lovely to meet you here at the Nuvoton stand at Embedded World 2023. Now, you're demonstrating here some interesting time-of-flight cameras.
Yes.
How are they going to be used in the automotive space?
Okay. Thanks everyone. I'm Jenny. That shows this demonstration. The first one, this is using our 3D ToF technology sensor in the automotive parts. And how does it work? We have this kind of detection by our 3D ToF sensor. Then actually customers, we can detect the driver's status, whether it's sleeping or not, eye is open or closed, or even you have the different direction of your eye, like switching from left to right. We can use this kind of a 3D ToF sensor to impress this kind of situation and to try to alarm that driver is not sleeping, or even they cannot use the phone, or even the dangerous things that happens when you're trying to drive. Yes.
So the camera itself is a time-of-flight camera. We're collecting lots of 3D data in that short space. And it's able as well to detect other things like the use of a mobile phone, or even if the person's smoking. Is that correct?
Yes, that's correct. So not only the status about the driver itself, but also when you're using the mobile phone, or even the one that you're smoking. And also I think there's a one that without some unsafety things, then those behavior can be detected by our 3D ToF sensor.
So Jenny, a big application is object detection.
Yes.
What are you offering here at Nuvoton in order to help customers who want to do object detection with cameras and processors? Okay,
so let's introduce our latest MA35D1, the latest microprocessor. This microprocessor, we have like dual core A35 core inside, and also a real-time M4. And of course we have like the camera, so we can have the CMOS interface to connect with the camera, then can detect the how many objects, or even the human being, how many human being count inside this product. Of course that we can run in the TensorFlow Lite, so you can have the very good well training of the big data. And so here you can see the result about the people count, and also the object detection of the result from our screen or monitor, or even LCD panels.
So we've got two very large, powerful processors there, and then we have the M4 core for real-time performance. How do those two processors communicate with each other and share information successfully?
Okay, that's a really good question. The first one is that A35 that runs on the Linux-based Linux OS. And the one that M4, we do the real-time job, and M4 is basically runs on the RTOS. So like the communication is like the mailbox interface to exchange the data and the transmission between each other. So that's how they communicate with each other.
Super. Well, thank you for guiding us through the demonstrations here on the stand at Embedded World, and we're looking forward to seeing what else comes out of Nuvoton in the coming year.
Yeah, thank you.